Okay, I think we are now live on YouTube, getting ready for the Gestalt IT Rundown here. Tom, excited. We're not doing the show expressly remotely. We usually do this remotely. We just live in different places. This is not a safety precaution in any way. But still, I'm glad you can be here. Although the digs look a little different this time around. A little change in the studio setup.
Yeah, well, while everybody was out buying toilet paper, I raided the fabric store and I have a curtain behind me now because let's face it, anything I can do to make this face stand out is awesome.
That's pretty much what I go with when I choose the thumbnails for each of the episodes. So I'm glad we were of one mind here. Are you ready? We got a ton of chip news this week. So are you ready to run it all down on a weekly show that's called the Gestalt IT Rundown?
Let's do it.
Was that was that a smile? I sorry, I was looking at my camera, not at you, Tom. I'm sorry.
Yeah.
All right, well then let's get it started. Then we'll do it in three, two, one. Hello, all, and welcome to the Gestalt IT Rundown, your weekly look at the IT news of the week. I'm your host, Rich Stroffolino. I'm an editor here at Gestalt IT. Joining me from across this great nation of ours is the one, the only Tom Hollingsworth. Tom, welcome to the show.
Hi, Rich. Thanks for having me on.
Absolutely. So we are going to get started with the news of the week. Right now, we have too many stories to cover in full discussion, so we always get it started with a little something we like to call news or not, where Tom's going to tell us if it's newsy and kind of why or why not in a real brief fashion here. Hence the need for a separate segment. First up here, we have some news from Google. This was supposedly supposed to be an MWC announcement, but Google Cloud announced a new telecom focused solution, Anthos for Telecom, very creatively titled. This brings their multi cloud application platform with Kubernetes support and tacks on some specialized services for telcos. Google Cloud is also launching the Global Mobile Edge Cloud service, which will let telcos run applications across Google's Edge network rather than just using their 20-ish cloud data centers, hopefully getting your compute closer to your endpoints, giving you a little less latency. OpenStack still has decent penetration among the telco crowd. Is Google Cloud going after that market, Tom? And is it news or nah for the launch of Anthos for telecom?
I wouldn't say it's necessarily news because a lot of places are starting to launch this edge compute Kubernetes stack to replace OpenStack deployments. I talked to a company, Mobile Edge X, that's doing something very similar, but from the VMware perspective. They've partnered up to do that. I don't necessarily think that Google doing it is news, but I think that the larger trend of having companies that are going to be going after this market is telco providers are probably one of the last, if you want to call it greenfield cloud deployments that hasn't really been tapped. So expect to see
Hmm.
something on that pretty soon.
Next up here, another update in the continuing story. That is the Pentagon JEDI contract. Previously, Judge Patricia Campbell Smith of the U.S. Court of Federal Claims ordered the Pentagon to stop work on the JEDI contract while this kerfuffle was worked out, pending a lawsuit by Amazon. Now, unsealed documents from a federal judge say that the Amazon lawsuit against the contract award is likely to succeed on the merits. This isn't a ruling, this is just a look at their evidence and basically saying it has merit and should definitely go forward. The judge found that the Pentagon made a mistake in evaluating prices for competing proposals from Amazon and Microsoft, and that the mistake would materially harm Amazon because I guess even $10 billion is a lot of money for Amazon. Tom, news or not on this latest update for the JEDI contract?
So I'm trying to decide if Amazon was the one saying I have the high ground or you underestimate my power. Um, Crappy prequel memes for the win. I here ultimately is the thing. Yes, the judge was absolutely right in this. So it's news because anytime a lawsuit has merit, that means that it will go forward. Now the question is, what's going to happen in discovery? Uh, Fun fact: all of those things that anyone has ever said that would lead the plaintiffs to believe that there was a preference for a specific provider in this contract, that's all going to get read into the record. So, way to go, government.
Yeah, we will see once this actually kind of the actual lawsuit gets to court and we get some more discovery on that, where it goes from there. But We'll keep an eye on it and keep you updated on the rundown. Next up here, Nvidia has been building out its data center business in recent years and acquiring IP basically across the entire stack for kind of their AI HPC market that they're really pursuing. Now they've announced they've acquired SwiftStack to add some object storage and data management IP into the fold. NVIDIA plans to use the tech for AI and high performance computing and accelerated computing workloads. And SwiftStack will continue to support their open source tools. Getting into that object storage game, high performance object storage, I should say, Tom, news or not here?
More news for the SwiftStack people. Congratulations on the pickup. Google has this really weird way of buying components that they need for things, and then those components just kind of disappear into thin air. Then are
NVIDIA, Tom,
later killed.
NVIDIA.
Oh, why did I say Google?
We
That's my
have, I
fault.
think this is buffeted between two Google-ish stories, so you're good.
Yeah, okay. My apologies. Still a good pickup for SwiftStack. Nvidia being the pickup here, I think that this actually does matter for them. My analysis is Google doesn't need any more storage. Nvidia, on the other hand, does. This is something that can be very handy for them. I mean, think about all the data that you're generating when you do AI and ML. That's needs to be kept somewhere, and you need a scalable solution that isn't going to barf as soon as you hit like 2 terabyte file lot sizes or something. Object storage is obviously the way to go, and SwiftStack is one of the best object stores out there. So my apologies to the Nvidia people. Good work.
Yeah, and it's interesting that NVIDIA previously has partnered with other storage companies. I'm thinking of Pure Storage with their Aries solution to kind of tack on, not tack on, but to put their high end data center racks on top of some super fast FlashBlade storage. And I don't think this is a direct competitor. This is slightly a different market in terms of scalability and that kind of stuff, but shows that maybe they're not content to just do partnerships, looking to kind of build out their own stack, as it were.
Mhm.
Next up here, speaking of Google, Tom, Google launched TensorFlow Quantum, an open source library for prototyping quantum machine learning models designed to let developers create hybrid AI algorithms that use both classical computing techniques and quantum computer circuit simulations. Google says that TFQ works by taking quantum data contained in qubits and processing it with hybrid classical AI modeling to generate predictions about quantum algorithms. Microsoft's Azure Quantum and IBM's Q both offer similar services. So, I guess public cloud quantum simulation saturation, news or not here, Tom?
Ugh. Sorry. Are we still talking about quantum computer, public cloud, AI, ML modeling as a service?
Yes,
And if
yes.
you
The
understood that
giant
entire
market there is.
if you understood that entire sentence, we both have problems. No, okay, great. I mean, we talked about Honeywell building a quantum computer last week. If a thermostat company is building a quantum computer, you are not breaking new ground with anything that you've done. I mean, I talked to a company last week that's doing post quantum encryption stuff, and like they're literally talking about being able to detect, data tampering based on bit error rates and stuff like that. That's the dirty in the weeds quantum computing stuff. Just announcing that you have a quantum computer, passe, yawn.
Well, Tom, thank you though for giving us the thumbnail for use on this episode. So I really appreciate it. And finally, here on News or Nah, at AMD's Financial Analyst Day, the company announced their Compute DNA, a new CPU architecture optimized for data center compute workloads. They previously have their, I believe it was RDNA, which was their Radeon gaming focused architecture. CDNA will include the second gen AMD Infinity architecture. To provide high bandwidth, low latency interconnect between GPUs and CPUs with unified memory across both, optimized for machine learning and high performance compute workloads. Previously, AMD has had their Infinity Fabric, which they've used inside of their EPYC platform and kind of also between GPUs and CPUs. But that this next generation Infinity architecture has that unified memory, which I think is kind of interesting. AMD expects to launch the new architecture this summer. So, compute specifically designed for the data center. News or not here, Tom?
It's news, but only because AMD is finally catching up to where Nvidia has been for a while. Kind of going back to the story, Nvidia worked hard to build out all of their, CUDA processing systems and all of that other stuff, and then they had to go get a storage company. And AMD's over here going, wait, people are eventually going to stop playing Call of Duty. I need to do something. And so they're trying to break into that market. And it's kind of funny because you walk around to data center shows and you're like, why does AMD have a booth on the floor? Isn't Nvidia kicking their butt on this? So I think it's more a matter of getting them kind of on on par with where their biggest competitor is. I mean, this would be like saying, oh, hey, look, Microsoft finally launched a public cloud. Hopefully they can catch up to Amazon.
Well, what I think is really interesting about this, and kind of a couple of stories we've talked about over the past couple of weeks, is that this kind of next gen high speed interconnect. Not that their Infinity architecture is competing with something like CXI or CXIL, I think is the other one that's floating out there. Not to say that this is like the next gen PCI Express or something like that, but that these super fast, low latency interconnects that are kind of allowing components to talk to one another, and kind of avoid some of the traditional bottlenecks is really becoming the architecture story that we're seeing kind of at the chip level for a lot of these
Mhm.
companies. So I thought that was interesting, how that will play out and see if that can be a differentiator. And admittedly, is a catch up effort by AMD. All right, first up here for our discussion, we have all of the chip vulnerability news this week, folks, and it's all x86, and it's all not great. We'll determine how bad or not bad it is. First up here, Intel. You may have heard of them, Tom. They have a new vulnerability that impacts the Intel Converged Security and Management Engine, and it's worse than originally thought. Previously, we thought this was patched in May 2019, but security researchers now say that this did not fully fix the issue. For reference, the CSME cryptographically verifies and authenticates all firmware running on a system. And researchers from Positive Technologies found the bug can be exploited by malware with root privileges to recover the chipset key and grant an attacker access to everything on a device. Previously, it was thought that physical access was needed to exploit the vulnerability. For sensitive systems, the only recourse, guess what? Replace hardware. Yay. Only Intel 10th generation chips are free from this vulnerability. So, Tom, a patch that didn't fully patch the issue now being brought to light here. How serious should organizations be taking this with Intel?
Just like any other vulnerability, it's serious enough that, if they're releasing the fact that the patch didn't fix the problem, you absolutely have to be aware of what it's going to entail. You need to figure out how to, well, you have to work around it. And I don't know how you're going to do that. And if you have to rip and replace hardware to get to that point, strongly worded letter to the people at Intel for letting this thing go for so long. I mean, ultimately, to me, that's the issue. Like, you knew this was a thing. You tried to patch it. You didn't test all the aspects of the patch. And I get it. Attackers only have to get lucky once. But if attackers keep
Yeah.
getting lucky over and over again, that says more about the process than it does about the skill level of the attacker.
Yeah, and because we have a number of these to get through on the show, I think we'll maybe bring it around to like a larger, x86 architectural point here. But to kind of set up the next one, it's another Intel exploit, and researchers at Bitdefender and a team of academics published details about a new class of vulnerability for Intel processors. Yay, new classes. It's called load value injection, or LVI. This essentially is a reverse process of the speculative execution attacks like Meltdown that came to light in early 2018. LVI attacks allowed the attacker to inject code inside the CPU and have it be executed as a transient temporary operation, whereas Meltdown was able to essentially read the speculative execution and kind of exfiltrate data from that point. This is kind of injecting stuff into that pipeline kind of from the reverse process. The exploit was discovered independently by two sets of researchers, which tells me it's not good, and we're able to demonstrate attacking cloud environments and also to leak encryption keys from Intel's secure enclave. And the researchers say that a JavaScript exploit is theoretically possible. They didn't actually test that though. And particularly, this seems to really be able to be exploited in multi-tenant environments. Again, going back to that cloud use case. LVI seems to bypass many of the Meltdown partial fixes. Remember, there is no full, like, kind of one stop or one size fits all patch for Meltdown or the speculative execution vulnerabilities, with researchers saying that only a hardware fix can fully address. So again, rip and replace. Yeah, the exploit has been demonstrated on Intel processors. Unsure if ARM or AMD would be exploitable here. But Tom, is this fundamentally different? When I hear new class of exploit, injecting code seems like it could, it's one thing to lose data, to have someone be able to read data. It's another thing to inject something and be able to execute theoretically code, right?
Yeah, it is. But this to me is the logical outcome of all the research that's been done on Spectre and Meltdown forever. Is if I can read something from the pipeline, what's to stop me from injecting it in there? I mean, think of things like buffer overflow attacks or, SQL injections. I mean, yeah, if I can read SQL data, I can write to it. So
Mhm.
that's what they're thinking with this is if I can find a way to inject code in there, I can, cause pipeline issues. I can have small transient things get, executed and then disappear. I mean, think of like the ultimate form of a container. I mean, if a container is like the size of a bacteria, this would be like the size of a virus. It sneaks in, causes problems, and
Mhm.
gets out. When I say virus, I don't mean computer virus. I mean actual, legitimate, small, tiny virus. Um,
Mhm.
Ultimately, though, I don't know that this is something that can be fixed. I mean, yeah, when you say class, like this isn't just hey, we found a thing. It's we found a whole bunch of things that we could probably exploit forever. I don't know what the solution is. Like you said, rip and replace. I'm not ripping everything out. I'm not replacing all of my Intel hardware for this. I mean, that was the thing we talked about when Spectre and Meltdown came out. You cannot reasonably expect people to completely, fix all of this. And here's the ultimate problem that I have with it. You claim that you fixed Spectre and Meltdown and all these other problems in your latest generation of processors. Have you?
Well, and that kind of brings up the larger point here because the researchers themselves said for these LVI exploits that the danger of these actively being exploited, it's a fairly specific attack. Yes, they point to that JavaScript attack, but they said, this would be a very complex attack, maybe something akin to a rowhammer attack or something like that, where
Mm-hmm.
yes, it is bad, we need to know about it, but it's not like something you can just like look up some code on a hacker forum and be able to execute, at your mom and pop enterprise or something like that. It does require a high degree of sophistication to exploit. But their point was, okay, the more we can understand about where the problems are, kind of in this x86 pipeline, and architecturally where the problems are for this, then it will, ideally, this allows Intel, AMD, and anyone else designing processors to say, okay, speculative execution sounded really great. Turns out there's some fundamental flaws that can lead to unfixable security exploits, and and knowing that allows people to build better processors in the future. I definitely think this has been the security mindset on software for a long time, like break all the things, let me know that we broke all the things so that we can build better software in the future. I do think this is, Intel not being as prepared for that same kind of mindset when attacking hardware, mainly because, again, like you said, a lot of the times the only mitigation is we need new hardware.
Yeah. And the worst part is like when you break software, okay, I can patch that. When you break a processor, that was a design from what, 3, 4 years ago. That's
Yeah.
baked. That's not
Mhm.
fixable.
Yeah, I mean, yeah, theoretically you could like, have the cache clear in a different way or something like that. But like if it's fundamentally in the way the processor is designed, yeah, there's very limited mitigation you can do. And that brings us to our last x86 vulnerability. Hey, it's AMD's turn. A new paper from security researchers at Graz University of Technology in Austria, so that's why I'm probably pronouncing it wrong, claims that all AMD processors made from 2011 to 2019 are vulnerable to a side channel attack that could leak otherwise protected information. Sound familiar? The researchers reverse engineered AMD's L1D cacheway predictor, resulting in two types of attack. There's a collide and probe attack, which can monitor a victim's memory accesses on a time shared logical core, and load and reload, which can obtain highly accurate memory access traces on a physical core. So, obviously, the distinction between a logical and physical core, one has more implications in a multi tenant environment, for example, versus, getting local access to a machine. The researchers were able to run the exploit in JavaScript, run on Chrome and Firefox browsers, and also gain access to AES encryption keys, aka very bad. Compared to similar architectural vulnerabilities, though, like Spectre and Meltdown, the ones disclosed only leak a few bits of metadata rather than provide full access. So there is a smaller surface area. There's a smaller level of vulnerability, I should say, per each successful exploit. The researchers notified AMD of their findings on August 23rd, 2019, and AMD was really cagey about this. They basically said, hey, this was all kind of covered when we did this in 2018. These are not new speculation based attacks. Researchers from Graz were saying, yeah, this is something new. The previous mitigations are not solving this. So we will see ongoing if AMD what if AMD's changes their tune as more research comes out. But Tom, same story, different vendor, or is this something different here?
This is something different, but they're looking at the same thing. It's like I have 4 different buildings that I'm trying to break into. They're all different security levels and all different designs, but I'm using the same methodology for doing it. That's what this is. I mean, when you're looking at the branch execution and the cache, yeah, maybe they're getting less data or they're not able to take full control. Ultimately, the result is the same. We can get access to the stuff we're not supposed to be able to see. Where that goes in the future, I don't really know. And AMD seems a little bit cagey about how they're going to patch this, if they're going to patch it at all. So, realistically speaking, this is a wake up moment for people who build chips. I mean, you've seen this. Branch pipelining, branch everything is being attacked. And the worst part is, it's like when people get through those doors in buildings. If you don't have any kind of internal security set up, this is bad because then people have free reign. I mean, yeah, you're banking on a lot here. People have access to the processor. People know how to look for the stuff in memory. But I mean, this AMD vulnerability, they literally demonstrated it as a JavaScript vulnerability in Firefox. I mean, there's proof of concept code out there. That means you're broken and you're going to have to fix it.
I do wonder, as a broader question, if this, if we keep seeing vulnerabilities like this, toward again processors that the only mitigation is put a new processor in that it doesn't have this baked in. I do wonder if this will accelerate kind of the push we're already seeing for maybe composable or disaggregated architecture, where we're seeing more things bypass the CPU, not just from a performance bottleneck perspective, but maybe from a security perspective, and moving compute more directly into memory or more directly into storage, and some of the solutions that we've seen around that, maybe as part of a larger isolation play, not just a data gravity thing.
I could see that, but I also see AMD and Intel wanting things to run through the processor as much as possible to justify this race to have, like 11 billion cores or something like that. So fight all you want to have the storage array doing DMA to memory and other stuff. Just be prepared for the backlash when Intel, releases a 128 core monster that oh, we can run everything on a core or two.
That old expanded surface area has never caused any problems in, in the entire history of security. And
Nope.
finally, here, so maybe all of these x86 vulnerabilities opens the door to another architecture. Maybe, I don't know, ARM in the data center. Tom, drink. We have new findings from Anantech. They published a performance preview of Amazon's Graviton 2 processor, and it's second generation. It's the second generation ARM server chip that they'll offer in EC2 instances. They have a first gen, I believe they're A1 instances that they offer them. I thought this was interesting in terms of comparison from our conversation from last week, talking about Ampere's recently announced Ultra 80 core ARM CPU. It's based on the same basic ARM platform, but with some important differences here. For some details, Graviton 2 will offer 64 cores per socket, but with lower clock speeds and using less than half the power of Ampere's Ultra, which remember is 80 cores, so there is a substantial difference there. And Nantech points out that the Graviton 2 looks to be essentially a reference ARM Neoverse N1 platform. And offers 40% cheaper performance compared to existing x86 offerings. This may change. They note that they don't have figures from AMD's new Rome platform, which is their second generation EPYC processor line that's just beginning to start rolling out now. So that may change the equation somewhat, as it does have some substantial architectural improvements. But Amazon is about to roll out a vertically integrated EC2 platform that offers similar performance at a substantial price difference. Does this break your arm of the data center skepticism, Tom? I'm curious.
No, it doesn't. And I'll tell you why. Because in 2 years, you won't care. And I think ultimately that's the problem. Look at the cloud narrative so far. We need to take what we're already doing and move it to the cloud, right? So some things were already run in the cloud. A lot of things don't. It's probably less than half. But what's the magic word? Refactor. Refactor your applications. Rebuild them to work on the cloud. Make them, um, resilient and all these other things. Well, now if I have to refactor it anyway, who cares what processor architecture I'm running it on? I mean, a lot of apps didn't care in the first place. If I've got developers in the mindset where they have to refactor every once in a while, then I'll just toss out some cheap compute. And I don't care at that point as a developer. As long as my code runs, who gives a crap if it's running on Intel or ARM or what have you? I don't think that ARM in the data center is going to be the solution. What I think you're going to see, though, is home built devices. Amazon building their own processors, running their own storage arrays, running their own NICs. That's where the real value is. And what they're going to do is they're going to do like they do with their Amazon Essentials brands or their Amazon Basic stuff. They're going to offer it at cut rate prices. They're going to displace all but what I would consider to be the quality vendors in the market. But the difference is that this isn't like, oh, well, I'm going to order the Amazon's Basics backpack, but I'm going to get, like, the Black Diamond trekking poles to go with it. You don't get another option. Like, you can't say I'm going to run Amazon Basics CPU and storage, but I want Arista networking. This is it. You get everything. And eventually, as they keep moving up the stack to replace more and more things with their own custom equipment, you're going to start seeing vendors scramble to, honestly, I think what you're going to see is you're going to see them try to do the repatriation narrative, which is, hey, remember how we told you cloud was kind of important? You can still do that in your data center with outposts and our stuff. Please buy our stuff.
Yeah, I mean, it has to be a little worrying, with the scale that Amazon can operate at and the ubiquity that they already have, to kind of put that out there. And again, this is an early performance preview, but Anantech seemed very bullish on these performance figures, and that I think should have a lot of people worrying. Also, other public clouds that may be, we've heard. I know what is it? Alibaba Cloud is working on their own processors. There's been rumors that Google has been working on their own as well. I wonder if Ampere is setting themselves up ultimately to be acquired by one of these large public clouds to better compete in this space. If not being, bought by maybe a company like Intel that all of a sudden is on the outside, maybe looking in for the biggest public cloud provider, again, providing that kind of vertical stack. And yeah, I mean, ultimately, I think from an enterprise perspective, yeah, once we kind of get over this legacy hump, that we're just kind of, I don't even know if we're over it yet, but we all kind of realize that, like, okay, having things that are monolithic and not agile and all that stuff is not great when we're thinking about the cloud going forward. I don't see a lot of the organizations still maintaining that. Like, if you could start from a clean sheet, no one is going to, I think, build a monolithic app like that. So you're going to see things that are more dynamic, more versatile, like you were saying, Tom. And yeah, then it becomes a, okay, let me plug this into my expense calculator. Okay, I need this performance for this cost. Who cares what the processor is, as long as I can get it running without a lot of added expense.
Yeah.
So it will be interesting to see when that rolls out. I think it's supposed to be coming out later this summer, and we will see how the rest of the public cloud responds. And again, Amazon is not the only public cloud provider that's kind of operating in this space. We've seen Packet offering their own kind of, smaller ARM instances and stuff like that. Different story though when Amazon brings the big guns to bear. And speaking of the big guns to bear, Tom, thank you so much for being on the Gestalt IT Rundown this week. Always a pleasure, my man. Where can people find more of your great stuff if they're so inclined?
Oh, you can check me out on Twitter, Networking Nerd. You can check out my blog at networkingnerd.net. Still got some more RSA coverage rolling out on gestaltit.com. So just look for me there, and I can help you out with all of your security needs. Um, IoT, penetration testing, might even be some email security posts coming out soon.
And also be sure to check out, we have Tech Field Day happening this week. So head on over to techfieldday.com. We have the live stream going. Tons of great presenters, lots of great content. So check that out live all this week through Friday. And you can also check it out anytime you want on the YouTube channel for Tech Field Day. Just search for Tech Field Day on the YouTubes. But we'll be back on YouTube next Wednesday, 12:30, or this Wednesday. It's this Wednesday because it's the next Wednesday coming up. Anyway, every Wednesday at 12:30 p.m. Eastern Time. We're streaming live on YouTube, and then we're available later anywhere you want to watch us on gestaltit.com, our Facebook page, anywhere. And subscribe to the podcast feed as well if you're more of an audio person in general. Until the next time we meet, though, for myself, for Tom Hollingsworth, for all of us here in the Gestalt IT family, here's wishing you and yours to have a super sparkly day.